Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we are doing chapter 12D, question 14. So this is once again in your vector calculus projectile motion subtopic slash chapter. And this question right here is actually a very tricky one. And if you don't know your trigonometry rules, complementary angles properly, this could be a bit of a challenge, okay? So question 14, very short. Let's get straight into it. A body moves horizontally along a straight line in the direction n, so north, a alpha degrees west with a constant speed of 20 meters per second. If I is the horizontal unit vector due east and j is the horizontal unit vector due north, and if tan alpha is equals 4/3, find these two questions. Okay, so let's write down what this looks like first. So we know east and north would go this, whoops, I can't draw. So that's north. And that would be vector j, because that's what they told us. And then I, so I right here is the horizontal unit vector east. So east, and that is vector I. Okay, but the thing is, you have this body, this particle right here moving northwest. Okay, so northwest going top left with a constant speed of 20 meters per second. But the important part is tan alpha, the alpha that we know here is 4/3. So we know it moves northwest, that's all I know. Gonna move this way, gonna try to draw a straight line, and it's gonna make an angle of alpha to the north axis, and then your opposite would be 4 and your adjacent would be 3. Of course, we know this triangle, like it's a very basic triangle, your Pythag triangle. So if this is 4, that's 3. Pythagoras says this is 5. Okay, a squared plus b squared equals c squared. Right, now let's do some questions. Part A, the velocity of the body at time t. Because this is constant speed, that means velocity is also constant. Your velocity is just always the same regardless of time. Okay, so there should be no time at all. So if you want to do this, there is one important concept you need to know first. It's more of a physics concept, not explained in the textbook. That's why hopefully this video helps you understand how to do these questions and even more. So if you want to find the velocity, and it's usually initial velocity, but because this is constant, that means initial velocity means it's velocity throughout. If you want to find initial velocity, so v0 t, then the formula is your initial speed, so v0 multiplied by cos theta I plus v0 initial speed multiplied by sine theta j. Now what is theta? Theta just means the angle that the velocity vector makes with the positive horizontal axis. Okay, so that one right here, that's theta. In this case, they didn't tell us theta, they told us alpha, but that's where the complementary rule comes in. Now, what is theta equals to? So over here, we know that theta would be alpha plus a 90-degree right there. So theta is pi/2 plus that alpha that we're being told. Okay, so to find your velocity, it would be velocity. So actually, because it's constant, v0 is equals to v, and that is equals to initial speed, which is 20, and multiplied by cos theta. Now, cos theta is cos pi/2 plus your alpha I, so that's vector I, and then plus v0, once again initial speed, multiplied by sine pi/2 plus alpha, and that's vector j. Okay, now back to your complementary angles methods. 3/4 special 3/4 1/2 as well. How would you do this? Well, we need to convert it first of all into alpha because we don't know what pi/2 plus alpha is. Now, to convert a simple method here, there's also a rule table and all the theory, but for this video, I'm just going to show you a very simple trick. Okay, so 20, just leave it by itself. Now, when you're doing complementary angle, meaning your pi/2 plus minus alpha or your 3 pi/2 plus minus alpha or theta, then you can apply these rules. So cos always becomes sine, and sine always becomes cos. Okay, just change it that way. And then pi/2 plus alpha, or whatever angle they give you, just change it to the angle by itself. Okay, so that's a trick. Change that into alpha, and now there is the negative positive sign. So let's have a look first. Cos pi/2 plus alpha, that's in this quadrant, right? Now, cos is negative in this quadrant because all station to cofield or CAS right here says only sine is positive. This is cos, so that means you must have a negative in front. It's a negative number, okay? So it's negative 20 sine alpha I plus, let's have a look here, 20 is still the same, sine becomes a cos, and pi/2 plus alpha, any complementary angle, just change it back into the angle itself, alpha, and then over here we have sine, right? Sine is positive in this quadrant, so therefore we have positive, okay? So don't be confused. Yes, I know there's a cos here, but it came from a sine, okay? Right, and there we go. Now just answer the question. What is sine alpha? We know that tan alpha is 4 over 3. Sine alpha will be opposite over your hypotenuse, right? So that is negative 20 multiplied by 4 over 5, and then I, and then plus your 20 multiplied by cos right here. So what's cos? That's 3 on 5, okay? So 3 on 5, and then close your bracket J. Add some variety, add some colors, even though it's not that symmetrical. So I'm sorry if you're a perfectionist, guys. I'm so sorry. But let's just multiply it out. Negative 20 divided by 5, that's negative 4. Times 4 gives us the negative 16i horizontally. And for the j, that's 20 divided by 5, which is 4, plus 3, that is 12j, okay? Because we know this is constant velocity, constant speed, that's what they told us, then your initial velocity is the same as your overall velocities. Negative 16i plus 12j. Now just remember, this formula that we just used only applies for initial velocity, okay? The angle that it makes at the start, okay? Obviously you can do it for any other velocity, like wherever it is, but typically in an exam question they tell you the initial speed, the initial velocity. Okay, so that is part A. Let's do part B. Find the position of the body after 5 seconds. Very simple, okay? So part B, if you want to find position, so that's vector RT, all you need to do is, we know velocity vector, just anti-diff it. So anti-diff negative 16ti plus 12tj plus vector z or vector d, up to you really. And in this question right here, we just have to assume it starts from the start, so from the origin. So that means when t equals 0, you get 0i plus 0j. That means t equals 0 here, it's negative 16i plus 12. Because you have t equals 0, they just disappear, and you have vector d. So vector d is basically the 0 vector, so might as well just not write it down. So vector r, your position vector, is negative 16ti plus 12tj, and there we go. If you want to find the position vector after 5 seconds, just sub in t equals 5, or pretty much just sub in t whatever the question asks you. Negative 16 times by 5i plus 12 times by 5j. And if you do that, guys, you should get negative 80i, so negative 80i plus 60j. That's pretty much where you are. So if you're moving at this velocity, over time you eventually end up somewhere here after 5 seconds, okay? So that's your position, northwest, okay? And that's pretty much it for this video, guys. Part A was the confusing part. Hopefully you found it useful and helpful. Aside from that, guys, please leave a like if you did find it useful. And of course, I will see you in the next video. Thanks for watching.